Welcome back. Still on operations in logarithms, it is now time to learn division operations in logarithms of base 10. Alright? We can still use our logarithm and anti-logarithm tables just the way we perform multiplication to also perform division operations. Now we have some examples that tells us to use logarithm tables to solve these three questions. Alright? And let's go ahead to the first question. 36.12 divided by 11.22. So we have to use logarithm tables, alright, to perform this operation. As is the case with multiplication, the first step we always do is to draw our number and logarithm tables. Alright? Then we put the first number under the number section, 36.12, and then we find the logarithm of 36.12. Now, we've explained how to get the logarithms. So the logarithm of 36.12 is 1.5577. Then when we have divided by, what will it be in logarithms? Minus. So when two numbers are dividing, their logarithms will subtract. Alright? The second number is 11.22, and the logarithm of this 11.22 is 1.0500. If you do not know how to perform logarithm operations, how to convert numbers to logarithms, check out my previous videos where we will explain how to do so. The next step is to subtract these two numbers. Alright? So when we subtract this from this, we are left with 0.5077. Alright? So this is our final answer, but it is in logarithm format. We have to convert it back to being a normal number. That is what they want us to do. So what's the first step in converting to anti-logarithms? As explained before, you forget about this number before the decimal point, and then you find the anti-logarithm of these numbers first. Alright? So 50 under 7, difference 7, gives you 3219. Then, after getting the anti-logarithm, you bring out this 0 in your pocket. Whatever number was in your pocket, in this case is 0. That helps you to know where to put your decimal points. So 0 means it is at the correct position between the first two digits. That is the correct position. So our final answer is 3.219. And if you actually press your calculator, you are going to get this. You are actually going to get 3.2193. That tells you that what we are doing using our logarithm and anti-logarithm tables is correct. Alright? So you see, it's just a case of knowing how to use your logarithm tables very well. If you know how to use your logarithm tables and you know how to use your anti-logarithm tables, you don't mix them up, you are good to go. Alright? That is basically what this part of logarithms involves. Now let's check the second example. Example 2 that says 808.3 divided by 41.24. Alright? As always, the first step is to draw our number and logarithms table. And then we fill it in with these. 808.3. When we find the logarithm of 808.3, we get 2.9076. Dividing, since it's dividing, our logarithm will minus 41.24. When you find the logarithm of 41.24, you get 1.6153. Alright? So what do? Simple subtraction. When you subtract this from this, you are going to get 1.2923 as your final answer in logarithms. But then you have to use anti-logarithm table to convert it to a number. So when you use anti-logarithm tables to convert this to a number, you are going to have 19.60 as your final answer. And if you really punch a calculator, you are going to actually have 19.5999. So if you notice, whatever you get with your logarithm tables is always approximately equal to what you get with your calculator. So it's really easy. The only thing you have to learn here is how to use your logarithm and anti-logarithm tables effectively and efficiently. Once you know how to use your logarithm and anti-logarithm tables, the only other thing you need to know is that when numbers are dividing, you have to subtract. If they are multiplying, you have to add, and you are good to go. Now let's solve the third example, which is 67,800. Alright, since it's here, no need to waste time. 67,800 divided by 8.71. So first of all, 67,800, when you convert that to logarithms. Alright, don't forget how to convert to logarithms. Your decimal point is here. You move 4 times. 1, 2, 3, 4 to get to between the first 2 digits. That's where we always want to arrive. So we move 4 times, that is 4 points. And then you go to your logarithm tables. You look for, even if there are 5 digits, take the first 4. 67 under 8 difference 0. And that's going to give you 8, 3, 1, 2. Alright? Then divided by, you put your minus. Don't forget. 8.71. When you find the logarithm of 8.71, you are going to have 0.9400. So when you subtract this from this, you are going to be left with 3.8912. This is your final answer in logarithms. But converting to a number, you use anti-logarithms to solve 3.8912. Alright? You keep these 3 in the pockets. Then you find the anti-logarithm of 89 under 1 difference 2. When you find the anti-logarithm of 89 under 1 difference 2, you are going to have 7784. And then when you bring out these 3 in the pockets, this is the 0 position, this is 1, this is 2, this is 3. So your decimal point comes here, which means your final answer is 7784.0. So that is it. And if you actually press your calculator direct, you are going to have 7784.15, which is approximately equal to what we got with our logarithm tables. Alright, so that basically is it for division. You just need to know when and how to use your logarithm tables. So when you are moving from a number to a logarithm, you use your logarithm tables. But when you want to move from a logarithm back to number, which is only done once to get a final answer, you use your anti-logarithm tables. Alright, so as always, I'll give you some examples that you can try under division. Alright, just try and perform these division operations. Alright. And also, alright, now try and solve these examples. Let me know the answer in the comment section, and I will give a shout out to the person who answers it first in my next video. Thank you very much.